dictionaries. And dictionaries is one thing that you will use quite often in any programming language. If you're coming from a background in other programming languages, then you probably are familiar with the concept of maps. And dictionaries are very similar to the maps. Dictionaries are also key value pairs, as you can see on the screen. So there are a bunch of keys, and each key is associated with some value. Dictionaries are type safe, that is, you define what your dictionary looks like, whether it's a dictionary of string mapping to an int mapping to a string, a float mapping to integer, a float mapping to a string, or any combination of these. But once you define what your dictionary looks like, you cannot go in and put in values other than the values you have committed to put into those dictionaries. The other item which you should be careful about is just like sets, dictionaries are unordered, which means that if you put some values in dictionary and then you try and retrieve them, you can't expect the values to come back in the same order in which you added them in the dictionaries. You will have to write your own algorithm in case you want to sort the data in such a manner. For example, while retrieving, if you want all the keys to be sorted in the descending order, or you want them to be ascending sorted by strings, you will have to go forward and do that on your own. By nature, dictionaries will be unordered. Now let's start looking at some examples, and like we have always done, we are going to directly jump into code. And in the example that we are going to talk about, we are going to consider the example where there's a dictionary of a student ID being mapped to a student name. Simple example, I have a bunch of student IDs and I want to map them to some student names. Now, could have been an integer mapping to a string, but in my example, it's basically a string mapping to a string, and I'm putting up a hypothetical student ID named yup01, and it keeps going on from that point onward forward. So it's alphanumeric, and it always maps to a student name. Of course, it can be a full student name, and for this example purposes, I have just gone forward and put in the first name. So let's say we need to give it a name. So we're gonna say where student dictionary. Yeah, so that is good. And then we define a dictionary format very similar to the way we define our arrays and sets. So we go forward and we say, okay, I have a student name, and the student name is mapped to a student ID is mapped to an actual student name. And I then go forward and add other items like I did the first one. And again, of course, keep going on adding others, but I will not bore you by adding everything right now. We will add them where I show you how to go forward and add more items into the dictionary. But now I created this variable student dictionary, and the question comes up is it truly a dictionary? How can I be sure? So let's check the type of student dictionary like we have been doing all along. Let's see what it is. It is indeed a dictionary of type string and string. So it is a dictionary. Unlike sets where we had to explicitly declare a set because there was a conflict with arrays and by default it was being assumed as an array, dictionaries are unique because dictionaries are a key mapped to value. And there are a bunch of keys, everything mapped to a value. And it's given by this unique syntax where it starts like a array, but then it has a colon, which is a separator, before a comma delimiter to identify different elements inside the dictionary. So it is clear to Swift that you're trying to define a dictionary and not really an array or a set, so you don't have to explicitly define it. Now, you could have, if you wanted to, and I'm gonna go forward with another example, and let us say that, okay, I have another dictionary of synonyms, okay, and very common. And I could have gone forward and said that my dictionary of this synonyms is of type dictionary, and it's going to be a mapping of two strings that are synonyms. Okay, and I can go forward and define that. So now synonyms is, and I'm just printing the synonym here, but of course at present the problem is I have not initialized it, so that's going to be an error. So let's go forward and do this. So okay, it is a dictionary of type strings as I defined early on. It's it's explicit, or it's type annotation approach for defining synonym as a type dictionary. And here it is type inference, where based on the value, Swift is able to assume that it is of type dictionary, string is string. Now, in either case, once you have defined your dictionary, if you want to add new elements to the dictionary, all you do is that you refer the dictionary by and tell it what key you're looking for. Now, in arrays, you would have put in the starting square brackets and ending square brackets index, which you want to actually refer. Here, you will actually refer to the key. So let's say I want to refer to year 3, and I'm saying the value of this element is Sakara. And since I do so, I've added a new element to the dictionary. And to make sure that that what I'm saying is actually true, let's go forward and just see what is the content of student dictionary. And of course, I can hit this icon to see the values, and you can see that okay, yes, Sakara is now present. But you see one more item, and that item is that I had Yapo 1 added first, I had Yapo 2 added second, and I added Yapo 3 as third element. But when I start to view it, at that point in time, O3 is coming in the middle and O2 is coming at the end. So, which proves the point that the dictionaries are basically unordered and you should not rely on any order being returned. For example, if you go forward and you refer to all the keys that are present inside the dictionary, which I do by studentdictionary.keys, I now see, when I click on the expand button, okay, here, I now see that, oops, um, let me just expand this guy up. I now you go and see that it's Yapo 2, 3, and 1. Again, it's returning in totally random order than the way I'm adding it. And if I was relying on order, saying that, okay, well, as the elements are added, I'm going to get that back in the same order as the elements, then I would not be getting the result that I'm expecting. So important stuff, dictionaries by default are unordered. They are key value pairs, which we have talked about, and they are type safe. So let's test the type safe piece now. Now I have student dictionary, okay, all good. And I know that the keys are string. So I go for, say, 04. And now I try and define a floating point number as a value. Now this should error out and saying that okay, cannot assign value of type double to subscript of type string, because Swift knows the dictionary is of type string string, cannot be of type string double all of a sudden. You need to use the right type. So yes, dictionaries are type safe. You cannot go forward and do these operations. Now let's assume that you want to delete something from the dictionary, and I go forward and say, okay, well, this I have O2 and I'm going to assign it the value nil. Okay, let's see what happens. It did not error out, right? But does that mean that now the dictionary has yep O2 present inside it with the value nil or no value at all? Let's explore. As you can see, and I'm going to remove the keys and just have the student dictionary present above as well. And I'm gonna expand the student dictionary up and below. As you can see, just before this line, yup, O1, O2, and O3, all three were present. But when I signed the value nil to O2, it's not only that the value is nil, the key itself is getting removed. So that's the way you will actually delete a key from the dictionary. Now, of course, another item is that dictionaries can be variables or the dictionaries can be constants. And I'm going to show you this with the example of a lad. If I change the var to a lad, now suddenly I cannot go forward and do any assignment operations because It's let, it's a constant. I cannot go forward and change a constant. So let's go back and move it back to the where so we can continue. And yes, with vars, I can go forward and make the changes. So now you know how you are going to add elements to the dictionary. You know how to delete elements from the dictionary. You know how to get the entire key set of the dictionary, student dictionary.keys. And of course, it is useful operation to go forward and try and get both the key and the values out of the dictionary using a for loop. Now, that's something that's going to follow a bit later because what's going to happen is that you need to know the control statements and the control loops. And once we reach the control statement, control loops, and talk about if else, the whiles, the switch statements, and we talk about the for loops, I will cover this topic again on how to simply go forward and print the contents of dictionary. For now, you don't have to because you can just use the results pane to actually see the contents of a dictionary. And just to make sure we checked out all the points, we covered the point of key value pairs, we covered the point of unordered, we covered the point of type safe. And yes, this is something good. Um, what we are trying to point here is that dictionaries can be complex data type and don't necessarily need to be just the simple types that we have talked about so far. So couple important points which are left to be covered, and let me just go forward and do some cleanup of the code here so we can actually focus back on the main picture. Um, the other element which we want to focus on is, let's say we're going to talk about is, okay, I have inserted some values, and of course at present, I'm just going to print those values again. I have three values which are inserted into the dictionary, YAPO1, YAPO2, and YAPO3. Now I'm going to try and retrieve a value out of the dictionary. And the way I do it is that I'm just going to say, let me show me the value of YAPO3. Okay. Simple, and the value is Sakara, as you can actually see. Now I'm going to run a type of operator and see what's the type of the value that was returned back to me. And you see, even though the printed value here was Sakara, which is the string, the returned value when you do student dictionary, YAPO3, is actually optional type. Then the reasoning is that you have a dictionary of integers or string integers and integers or integers and strings, strings and strings, strings and integers, and combination. There is no guarantee when you look up by a key that a key will be present in dictionary. So the value that is written back to you can be nil. And we know in Swift the return values cannot be nil by default. And if you want to allow nils, you have to use the option types. Since your values were of type string, you get an optional of type string back when you actually retry and access a value of any key inside student dictionary. And it's not for YAPO3, it could have been for any key, but you will get an optional type of string. And we have already said that, okay, I'm going to try and print this value, and you're going to see a warning come up. I'm trying to print this value here. Okay, so it prints a warning because it's saying that, okay, you are trying to implicitly get a string out of the optional string. And when we cover the topic on optionals, that is in Swift, the recommended way of accessing the element inside the option string is if let defining a constant, which is value, and saying that, okay, if this value is present, then go forward and assign that value by unwrapping the optional into the keyword which I'm providing here, which in this case was value. So I'm just going forward and saying print this value, but now I have unwrapped the optional and got the value inside it. Now in here, if I would have gone forward instead of 1 with O10 because there was an accident that I did, I get back a nil. And since it's a nil, this condition would have taken care of making sure that I'm not trying to force unwrap a nil, and I'm not running with the runtime exception. And my code will fall into the else condition, where I can simply say that, okay, no, no value found for key. Yep, 10. Okay, and as I run it, you will see that that's what's getting printed. So that was about how the values are optionals. The last element, which is just food for thought for you for around, is that here I went forward and said that, well, the student dictionary is a string and a string, but that doesn't necessarily need to be the case. The student ID could have a complex relationship, like say the key can be a string and the value can be an object. It can be a complex data type like an array. So I could have said it is Frank and with some Frank Mohatra, some random name. I could have gone forward and said, okay, Chris, and it is Chris Rockstar. Okay, so I could have chosen any combination. Okay, and the idea is that all you have is a mapping from a key to an object. The object could have been a string, but instead of a string, it could be your custom defined object, which is something that you define. It could be an array. Now, if I start looking into this object and try and see what it maps to, it will be a dictionary of string mapping to an array of strings, right? As you can see, you can even go value further and say that my dictionary can be of type string mapping in its value to another dictionary. So this is a dictionary which is mapping a key to another dictionary way of key and value mappings. And um, this is a very powerful feature, and it's present in all languages. I'm not saying that it's very specific to Swift. It's a feature of map, and it's very, very powerful. And the reason I'm bringing this up is that you will end up using it a lot in your programming practices, where you have to actually store complex amounts of data and you need to have some sort of relationships mapped into those. Because if you start looking at even this example, ideally speaking, your student ID should be mapped to a student object which could have n number of attributes mapped to it. If it was a mapping of OP courses that your college offers, then the course ID will be mapped to a course object, which could have hundreds of attributes defining who the professors are, what's the length, what the schedule of the course looks like. Uh, and you will be using this whenever you build any application which is trying to solve an enterprise problem. For now, that's all you need to know about dictionaries. And as I promised, once we reach control statements, we revisit dictionaries to see how we can easily loop through the contents of the dictionary. Thank you.